Alright, so I know these 30, 60, 90, 45 triangles can be really difficult, so I'm just going to run these 8 problems, and we can do those together and see how that helps. So I do need to pull out our handy dandy little sheet here that has our relationships on it that we're going to use for all of these. And these relationships you don't have to memorize. We proved them earlier by showing some patterns, but we'll always have them with us to review. So let's do this very first one here. So first off, I need to figure out 45, 45. Yep, so we're going to use this. So let's use the second, which means these two sides are equal because it's an isosceles with 2 equal angles. So if this is 3 radical 2, then this is 3 radical 2. And to find out this side, we take whatever the x is. I'm going to say x for all these because when I write s, it looks like a 5. So I'm just going to switch those. Alright, so let's see. How do we get this side? We take whatever x is, which is 3 radical 2, and we multiply it by radical 2. Alright, let's do it. Multiply these, which is radical 4. The square root of 4 is 2, and we still have to multiply 3 on the outside, so that makes this 6. Okay. Alright, next one, another 45. It looks like the whole top row is 45. Okay, so let's take a look at this one. Right now we have this side. Okay, pause and ask yourself, what does that equal on that? Okay, and I hope you said, I'll just actually fold this here so I can solve them under here. Okay, I hope you said that this side, 20, equals the x square root 2 side. So I can actually just set this ratio. Let's solve it and get x by itself. Alright, these cancel. X equals 20 square root 2. Here's the problem. We can't just keep that. We have to rationalize or get that radical off. So I'm going to write it again over here. And I'm going to multiply it by 1, a very unique looking 1. And that would eliminate this square root. And I can still simplify that fraction. Our final answer is this. And that's for both sides. Alright, let's try the next one. Okay, ask myself same question. We know it's a 45, so what side do I have? And it looks like, I hope I heard you say it, we have x, so these two sides are the same. Okay, let's follow the rule. We know the last side is this, and we have x, so let's plug it in for that. There's the x, and we still have to multiply by radical 2. Let's multiply these together. That's going to be radical 6, 4, and that's our final answer. Alright. That went really fast. Again, what we did was we already had x, so it's much faster. We take it and we substitute it in our evaluate it. And we want to remember from algebra 4, just place it right here where that x is. Anything on this side compared to this side has to be multiplied by radical 2. So we took the x, we multiplied by radical 2, and there's our answer. Alright, last one. Again, it's this triangle here. I have this side, which is this side. Okay, I'm going to give you a minute to pause, and then I'll work it out silently, and we can see if we get the same answer. Alright, let's see if we did. This side equals x radical 2, just like we did on this one over here. Set up the same way, we solved the same steps, except this one had this nice mathematical thing happen where this canceled on this side and ended up canceling on the other side, so we just ended up with 16. You could also think about this as we know whatever is in front of the radical 2, if there is a radical 2, is x, and so we could just use that relationship there. Alright, there is 45s in review.